So hello everyone. Welcome to the first ever DevOps Exchange Barcelona. Probably the sunniest event we've ever actually run, and I don't think I've been to a meetup before in short, so it's a bit different for us. Firstly, just huge thanks to the guys at Adevinta. For making this happen. We really appreciate your hospitality and your support. Obviously, we're looking to make this a regular event as well. So if any of you have got a space similar to this in your office that you're keen on hosting events like this, then get in touch with me or one of the Doxelona team. Just a bit of context as well behind the DevOps Exchange brand. So I don't know if anyone's been to a DevOps Exchange previously, but we run events in London, which is our biggest event. I think it's the world's biggest DevOps meetup in terms of member numbers, apparently. Bournemouth on the south coast in the UK, and San Francisco, which has been running for about 3 years as well. Hopefully the Barcelona event will be as successful as those we can give back to the community here. Recap on the agenda today. So I think you've probably all seen this on the meetup page. But first of all, we have Mark, who's actually one of the co-organisers of the meetup. So he's giving us an overview on the DevOps journey and how to get there painlessly, which we'll see if that's possible or not. Then we've got Ruggero talking about embedding security into DevOps. So DevSecOps is obviously quite a hot topic at the moment. Daniel from Adevinta, securing shell access to EC2 instances. And lastly, Girish, who's actually speaking at KubeCon tomorrow. So he's giving us an overview on service meshes. So other meetups as well. Obviously, we're very much like a community event here, and we're not the only show in town. There are other meetups going on. You can find all these on the meetup page as well. So there's a Kubernetes meetup on Thursday. Kubernetes Barcelona is next week as well. And there's also, if you're about in Barcelona at the beginning of June, there's a DevOps Barcelona conference. And Mark and Ricard are the organisers of this. So Ricard's just going to give us a couple of quick words about the conference.
Hi, everyone. This was not ready, so I haven't got a speech or anything. No worries. So basically, we've got this little conference in 2 weeks from now. It's starting on the 4th of June, Tuesday. Mark will open the conference, so if you like his talk, you can come again to see him. And yeah, basically, I mean, we've got right now, I think it's 300 plus 350 people coming, so hopefully we'll get to 400 people. So it will be quite a decently big event, I would say. It's in the AXA Auditorium in Diagonal, so nice venue. And yeah, if you want to come, we can share some code discounts at the end of the meetup or so in your website. So, well, in the meetup page, I mean. And yeah, thank you for this time. Thanks a lot, man.
Yeah, no worries. Cheers. And also, we are running a meetup, so it'll be a DevOps Exchange Barcelona on I think it's the 5th of June, isn't it? Yeah, so we'll have one in the evening during that conference as well. So a quick message from our sponsors. So obviously we want to keep this a community event. We don't want to make this a corporate event with loads of sponsors and things like that. But obviously it wouldn't be possible without people actually organising and paying for stuff like pizza and beer and that kind of stuff. So we are LinuxRecruit. That's where I work. Obviously we're behind the other events I mentioned earlier. We're a UK-based agency, but we're actually setting up a new office in Barcelona. So Jack, who's over there in the nice red shirt. So him and his team will be covering the whole of Europe, including Barcelona. So if you want to have a conversation with us after, find the three guys in the shorts, the only three, and Jack, and that'd be great. But also, obviously, it wouldn't be possible without the host, so a quick word from them as well.
Hi, so Adevinta is quite a new brand. We recently had an IPO in Oslo Stock Exchange. Sorry, I'm mixing words. We demerged from Schibsted Media Group. It's a Scandinavian media house that had a lot of marketplaces and media sites. In Spain, we are mostly known because from the brands like Fotocasa and Mil Anuncios. Like you actually, these, you can see them. But we have presence all over the globe, like in 16 countries, in Europe, South America, and North Africa. And that's it.
Great, thanks very much. Cheers to that. Yeah. And yeah, normally after our events, we have a tab at a local bar or restaurant. So if you want to continue the conversation after we have to leave here, then there'll be somewhere that we will be going. And one last thing as well, I've just been told that we have a new Twitter handle, which is Doxelona. We've got 1 follower at the moment, which is me. So if you want to follow us, there'll be news and stuff like that about DevOps and obviously videos for our events and stuff like that. So yeah, hope you enjoy the event. Cheers.
Hello, welcome everyone. How are you? Cool. So I've given this talk in the past in the All-Day DevOps conference. It's a global 24 hours a day conference happening, I think it's normally around October every year. Have anyone attended that before? No? Maybe? So have a look at the website. It's All-Day DevOps. It's quite interesting because it's for free. So you can watch it from your home or from your work, and you don't have to tell anyone about it. So who am I? So my name is Marc Cluet. I'm originally from Barcelona, but I've been living all around the world for the last 16 years. I have a company in the UK called Yukon Cherry. I organize the 2nd biggest meetup in the world called London DevOps, which is almost as big as DevOps Exchange London. And I also organize DevSecOps Days London, which is once a year. It's a conference, one-day conference on DevSecOps. And now I organize DevOps Exchange Barcelona as well. Thank you for that. And I worked in many companies, some of them startups. I work here in Grupo Intercom, if somebody remembers that. And in many companies in the UK, including Rackspace, Trainline, which is the biggest train operator in Europe, Canonical, who's the creator of Ubuntu, ASOS, biggest brand for teenage girls, so I don't think it applies to anyone here. And DevOps Group as well, which is a DevOps consultancy. And I've been doing DevOps for the last 10 years, even before it was called DevOps. It was called WebOps or something similar. Now I work at this place called Nationwide Building Society. It's a financial institution in England, and the main purpose is to ensure that everybody can afford a house. So it's literally that. That's the mission of Nationwide Building Societies, just ensure that if people want to buy a house, they can afford to, and they help people. So coming into the talk, so how to do DevOps, right? You've heard about this DevOps thing already. You're tired of listening to the word from recruiters and other people, but you look at what DevOps means, and then you see the objective, right? So the objective is going to the top of that, right? Top of that mountain, that's DevOps, that's Nirvana, that's all your problems sorted. And it's quite difficult because all you have is you're about to get your boots on, but you don't know how to get there. That's all you have. You have your boots, you know, you're willing to walk, you're willing to get there, right? But you have many questions. Questions like, how about uptime? Do I need to keep uptime while doing DevOps, right? How much this will cost. So do I have to hire new engineers? Do I have to retrain them? Do I have to buy new stuff? Do I have to go to this cloud thing or not? What about compliance? Will I still be compliant? What about all the old software? Because that's giving me money, that's running my business. So what do I do with all of these? What do I do with my current provider contract? So I have this data center for the next 2 years. Do I tell them to go away, or do I actually have to fulfill the contract? How can I uptrain all my current engineers? What about my job position? Will it change? Will I be out of a job if I do DevOps? What about or outsourced team? So it's quite usual in the UK and in America as well. They normally have one team located somewhere in Asia, normally India, that it gives you the 24/7 coverage. So it's like, what do you do with these guys? Do I have to tell them what DevOps is, or do I have to actually fire them and hire new Indian engineers that know DevOps, right? So how can we hire new people competing against big players? Because everybody's doing DevOps right now. So you have Google, you have Microsoft, you have Twitter, you have all these big players doing DevOps and trying to get all the talent away from you. How to get on board all the C-level executive, right? So you tell them, this is the new thing, it's amazing, it will save us money. But in order to save us money, you have to invest millions of euros beforehand, and it might not work. So yeah, that's not a really compelling thing to tell your CTO, CEO, CFO, whichever you need to speak with. And especially how this will affect my business as usual. While I'm doing all this transformation, will I still be able to serve all my customers? Will they be able to visit me, and basically will I still be able to run a business? And how are all of these aligns with ITIL and ITSM? So if you're running any of these practices, how can I actually do DevOps and be able to still run these, right? So these are all valid questions. But the important thing, I think, is to understand where you're getting at, so what good looks like. So if you read the State of DevOps report, this is published every year by a company called Dora, and it used to be published by Puppet before, but it's quite interesting because it's actually a very good view into what the world of DevOps looks like nowadays. And I would say Dora has identified from all the data from all the companies that have participated in this, there's actually 4 categories of DevOps maturity, also how mature is a company doing into DevOps. And all of these is measured by different things. I said deployment frequency, lead time for change, or how long does it take for actually from idea to production, time to restore the service, and the change failure rate. So for every release that you do, how many of them are successful, how many of them are not. And you can see that the differences are quite staggering. So a low performance team, it will deploy once per week or 2 once per month. The lead time to change, it's from 1 to 6 months. So just imagine having an idea and taking a full 6 months to take that idea to market. If all your competitors are doing DevOps and are more advanced than you, they're reaching market before you do. So it's not a good place to be in. And time to restore service between 1 week and 1 month. So yes, there's people that actually took 1 full month to get the service back. And we had some cases like that in the UK recently. There's a bank called TSB that it took them 5 days to get all the credit cards and all their online banking back online. So just imagine 5 days without your bank, without being able to pay anything, without being able to do any transaction. It wasn't good. But on the other side, you have this elite group, which is the aspirational, what you want to get, right? So the deployment frequency is on demand, multiple times per day. So for example, at Trainline, we were doing around 30 to 40 releases every single day successfully. Lead time for change, less than an hour. So from idea all the way to production, less than an hour, which is a bit insane, but it's doable. Time to restore service, less than 1 hour as well, because you're resilient, you know how to architect all your systems in order for them to be as resilient and highly available as possible. And the change failure rate is 0% to 15%, so it's very low. So you have a lot of confidence on the deployments that you're doing. So one thing that you can use is the CAMS method, which it sounds a bit silly, but you have to remember that, first of all, it's culture. DevOps is all about the culture. It's not about using new tooling. It's not about all the different processes. The first and most important thing, it's a culture. It's a way of doing things. It's a way to get things done rather than doing waterfall or any other kind of a scenario. Automation. So if it moves, automate it. If I have to do something twice, write a script, write some code, get it done. Lean, which means that you want to, all the pieces that interconnect, you want to go towards something like microservices or towards something like dependent services or serverless even. So things that are very small units, very easy to change, very easy to adapt, very easy to push forward. Measure everything as well. So anything that is in production or anything that should be in production needs to be measured. So the more metrics you have, the better. And I cannot stress that enough. It's very important to be able to measure everything because you never know what kind of information you get from that. And actually, all those measurements, they are not only good to indicate the direction you're going, but they're also very good for business intelligence. So you can do stuff like being able to develop new products based on all the measurements that you're doing. And sharing. So pair programming, code sharing, brown bag sessions, all of that is very important because you don't want heroes in your team. You don't want that guy that every single time that there's a problem will jump to the problem, solve it, and not tell you how he has done it. Right? You want things to be solved by a team. You want everyone to be confident enough to be able to solve anything that they want. And all of that define all the DevOps values. So those are the core things. And have in mind that none of them is tooling, right? So it's all practices, things that you should be thinking about. If you want to categorize them, it's mainly about learning and optimizing, right? So the sharing and measurement is learning. So you measure from, you learn from your measurements, you learn by sharing and optimizing what you have. You try to keep things lean. You try to automate as much as you can. But one thing that is very important, and that's where the pain comes actually in the DevOps transformation. If you want to go to DevOps, any kind of change creates tension, all of them. There's no change ever that has not created some kind of tension. There's no change ever that someone felt short-changed when that change happened, right? So I have a theory that is called the elastic band theory. So if you look at people, processes, and tools, as soon as you start improving one of them, that pulls the elastic band, and that makes the elastic band more and more tense unless you move the other one, right? So in reality, what you need to do is that to ensure as little pain as possible is to try to move the three of them at the same time. But have something in mind. They're also not equal. So people is the most important one. All that we do in the day-to-day is for people. If people are not buying your idea, if your team does not believe in what you're doing, if there's no clear vision and mission of that, everything that you do will be useless, literally, because they need to buy in. You need to ensure that everybody is on board with you on this. Then you create all the processes around that people, around the way that you want to work. And at the end, once you know the processes, once you know you want to do things, and that everyone agrees how to do things, then you find the right tooling in order to do that. So how many companies here, and raise your hand if you want, or keep anonymous, it's up to you, have first thought about the tool and then say, how can we actually adopt this process to get this new tool in? Because I've seen that personally. And that happens a lot, right? Or this new shiny tool like Ansible or like Kubernetes or whatever else. Let's just change everything because this is very nice. You're approaching it the wrong way. It's important that you have a very solid consistency in this. So once you're there, I would say you're kind of halfway there, right? So you're getting your feet wet a little bit with the grass, and you're going there. You pretty much know where you are. You understand what kind of things you need to do, what kind of things you need to stop doing, especially as well, and how do you want to progress. So once you're there, next thing, know where your teams are, right? So you have this great idea. You have buy-in from the CFO, CTO, whichever high level you need to convince. But the next thing is understanding all the different teams, the teams that are actually your customers, all the developed teams or product teams, finance teams, all of them. You need to understand and know where they are, right? So you need to start looking at all the application portfolio. Things like, can I actually migrate this to the cloud? Is this something that I need to redo? Is this something that it's a third-party vendor software? What kind of things do I need to do? Do I need to change my license? Do I need to do all the stuff? Talk about the development methodology. What kind of things are they doing to get something released? What kind of things are they doing to write that code, right? Are they doing unit tests? Are they doing continuous testing? Are they doing all that kind of stuff that makes things faster and more agile? If not, what do you need to get them there? The external dependencies as well. And this one is one that has beaten me so hard during the years. It's not only important to understand what you're doing, but also understand all those external dependencies, all those libraries that you are using, all that external source code that you're using, all of that, will that actually adapt to the way that you're working? Or will that actually create another breaking point? Will that create a problem for you? All the current processes that your team has, it's very important to document them, and understand why they have them. Because you cannot just change everything and don't ask them why they're doing things the way they're doing right now. It's very important to understand why they're doing things and try to buy them in by explaining to them how this new way of doing things will make their life better. The deployment methodology, and this one is another one that is quite critical. How are they deploying to production? Do they have a rollback mechanism? Do they have failure tolerance? Are they actually measuring time to production? Are they measuring as well the mean time to recovery if a deployment goes badly? Internal team dependencies. So that's also important. So if this team starts working faster, going agile, being lean, will that create pressure or tension with other teams that need to deliver components that this team will use, or the other way around? Does that mean that those other teams will feel unattended or will feel frustrated? What kind of things do you need to do with them to ensure that they are in line with what you're doing? The general satisfaction. So change creates tension, creates frustration. It's very important to understand that people are still buying into the idea, that this is going in the right direction. So one thing that you can actually do is every couple of weeks have a stop-go kind of meeting where you sit down with people for half an hour and say, are the things that we're doing working? What is not working? What do we need to change in order to get things through? The willingness to change as well. And this happens especially in all the companies. So I had this chap at Rackspace. He has been working in Rackspace for 15 years. Had a huge banner over his desk, 15 years employee, incredibly proud, incredibly happy to be there. You ask him, okay, what do you do? Like, well, yeah, I normally create users. So for this car dealer, like, okay, if this car dealer asks you to create a user, how many servers do they have? More or less around 500. And what do you do? Well, I have this Excel spreadsheet with the list of the 500 servers. I go one by one, create the user, then double check, and it's done. And it's like, do you get the 500 right the first time? It's like, no, normally that they have to call back a couple of times and complain that they cannot access with a new user to a couple of systems. But that's all right. It's part of the process, right? So this kind of guy, it's so convinced that he's doing his stuff right that unless you actually show him that you can write this script, you can do this thing, you do the 500 in one go, done. And you take him with you. If you do it for him, he will think that you're trying to take his job away. He will be scared. And you got a guy that knows everyone because he has been working there for 15 years. Is scared to death, saying that what you're doing is not worth. So it's important to take everyone on your journey and the willingness to change that they have. And of course, the knowledge bottlenecks. So this happens in every single company. It doesn't matter if it's a startup or a big one. There's always one piece or several pieces like, do you know how the system works? Well, I don't know, but that guy over there has been working here, and he's the only one that knows how this goes. Like, okay, what happens if the guy decides to quit? I don't know. We don't know what will happen with his system. What happens if this guy gets killed or decides to move to somewhere else? You're in trouble. So you need to identify those. You need to understand what are your knowledge bottlenecks. What kind of things do you need to do to make sure that those don't exist? And especially, you need to have a very clear target. In order to do a very clear target, it's very important to have vision, mission, and deadlines. Because you can inspire people, but unless you're showing them what you're doing and you're showing them that you're sticking to your deadlines, they will not believe you. So vision, said one phrase pitch, very clear about what you actually are doing. What are you delivering to your customer? The mission is slightly longer, maybe one paragraph, but how are you actually going to do this to serve this customer? And then the deadlines, you set business expectations. You say, in 3 months we'll be here. Okay, this is all animated and nice. There we go. So first 3 months, very clear objectives, very clear timelines, because if you don't know what you're doing in the next 3 months starting from now, you're already in trouble. So you need to understand, in 3 months we'll be exactly here, because there might be trouble, there might be problems, but I know exactly where I want to be in. I measure everything, have a feedback process that works. In the first 6 months, so the 3 first months and then 6 months, you need to have the next step objective. So rather than we'll be here, it's like we expect that we'll be doing this. And have aspirational timelines, right? So we expect that we'll be here in 4 months, because the first 3 months need to work in order to get there. So I'm not going to promise you that in 4 months we're doing that. The first year, completely aspirational objectives, not timelines, objectives. In 1 year, we need to have everyone knowing the latest technologies, the latest processes. We need to be agile, working in Scrum, having sprints every 15 days. That kind of things, very aspirational objective, nothing set in stone, no timelines. You say in 1 year need to be there. So you know what you need to do in those 3 months periods that you're doing. And after the first year, it's just aspirational everything, right? So in 5 years, we'll have an IPO and be super rich and live on a yacht and whatever, right? So you don't have to, I would say you need to know where are you going in the future, but you don't need to be specific about how to get there. Because as soon as you start giving the business exact timelines of things that happen in the future, that's the dragons that will kill you. Because then the CTO will come and say, you told me that in 1 year we will have 10,000 more customers, and we only have 9,000. So what are you doing to do about that, right? Cool, so you're almost there. You can see the mountain, almost the top of the mountain. You have some trouble. in between, some tension, some pains. But then you go towards the next thing, and that's the target operating model. So a target operating model is a very standard way to define how do you work as a company, how do you work as a team. So things like SRE, like DevOps, all of that, the only things that they do is define target operating models. So you need to find new ways of working, reduce human error. The 90% of the problems, whenever you hear in the news, this has been caused by a software problem, you can replace software with human, and you'll be right. Because humans are the main source of errors. If there's something that is a human process, it's prone to be wrong, because we are biologically designed to be creative, not to do repetitive stuff. If we keep doing repetitive stuff, we get bored, we stop paying attention, and that's when errors happen. Automate early, So shift contribution towards valuable engineering. We like challenges. We like to do things right. We like to have very big things that I can solve and say, yeah, I solved these. I'm pretty great because I solved this super complex problem. You don't want to go home and say, I actually added 2 lines to an Excel spreadsheet, go me. I mean, that's not solving a big problem, right? At least engineering-wise. Shift left security. Make security an integral part of your design. There's a lot of teams and a lot of, I would say, even a lot of companies that design a product, and then once it's designed, they say, okay, how are we going to secure this? If you're doing that, you're already late. Because security needs to be an integral part of your design. Because if you design security after the product, you're creating security holes already. You're creating a problem for yourself. Increase governance and standardize output. So it's important to have those guardrails, have that governance, have that way to ensure that everybody understands the rules of the game. Standardize all the outputs of your applications. Say RESTful APIs, it's a way to do that, for example. Just ensure that all your applications talk RESTful or talk pair or whatever you want to talk, but ensure that all of that is standard. Everybody understands what the expectations are for the application or the output and what are the rules of the game. For new organizational culture, which is part of DevOps as well, of course, reduce silos and bottlenecks. One of the biggest problems that DevOps is trying to solve is the hot potato problem, where one team does something, hands it over to the other team, don't want to know anything anymore about this problem, now it's yours. So any kind of problem, if it's a business problem, it's everyone's problem, right? So passing the problem over actually doesn't solve the thing, it just creates more problems. Create appropriate teams. Short lived is necessary. So create the teams appropriate for your product, for your objectives, because have in mind that there have been many studies about this, that the way that your application looks like, it's very, I would say, is very intertwined and connected to the way the team was created. So the way the team is organized defines the application, defines the output. So create the teams for the applications that you want to have. If you need to create short-lived teams that create one thing, that change again, do that. So for example, Spotify does that all the time. Make things easy. If somebody doesn't know how to use something, it's not because you're awesome, it's a bug, it's a problem, and it's your problem, and you need to solve it. Encourage constant feedback. Culture and process is always open to change. It's not something that you decide on a boardroom and you do it for the next 5 years. Go for it. So, for example, this is a model example from Spotify. Spotify is divided in tribes and squads. So the tribes are a group of people that always work together, so they know one another, they have that social connection, but they self-organize in squads for different projects, different problems. And as soon as the problem or project is solved, they disband the squad and create a new one. So that way, all the different problems are, in a way, are challenged and done with the right team in mind. The last thing, don't copy the models. Don't go around and say, oh yeah, I see this target operating model, it's amazing. I'll just apply it to my company as it is. No change whatsoever. Every company is special. Every company has its own problems, its own business outputs, its own needs. So it's important that you don't copy the model. You understand what you need to apply. So to get people on board, put people first always. Identify your champions, people that are very excited about the things that you're doing. They are the ones that will push you ahead. Create short-lived spikes to spread knowledge and culture as well. So if a problem is not understood, get people in, get people understanding the problem. So that way you share the knowledge while you're solving the problem. Ensure people are happy with direction and decisions as well. So I said that's part of that feedback. So for the application itself, chisel away the monolith, reduce the complexity and size of workloads to deploy because it makes things easier. You can deploy faster, you can do things faster, and there's a lot less dependencies. Design applications to fail gracefully. So don't expect the other application to be always available. If it's not available, what are you doing? It's your problem. It's not the other application problem. Ensure availability for external dependencies if possible. If you can do that, if it's integrated in the third-party application, ensure that you have a way to ensure that it's always available. And focus on reducing the blast radius. So every problem can be defined by the blast radius that the problem has. So that blast radius defines how risky is that problem for you. So if you design your applications in a way that you're reducing the blast radius all the time, I would say you're going in the right direction. If you look at applications in general, you can define them as anti-fragile, robust, and fragile. So there's 3 categories for software architecture of applications. Robust applications, like a castle, made to last, very big, very difficult to maintain, very difficult to move and change because it's a castle, right? But it's very difficult to also to crack and to have problems. Snowflake applications, they're fragile by definition. Applications written by that guy that left the company 10 years ago. Nobody knows how to change the code. And it's actually a core part of your business. You wouldn't believe how many banks have this problem because it's a big, big problem. And the kind of applications that you want to have more, the anti-fragile applications, like the Hydra, you cut a head, 2 new heads grow, right? So the applications that are designed for failure, they are gracefully failing, they are prepared for all kinds of problems, and they know how to act with them. So in order to deploy the application fast, automate testing as much as possible, differentiate between internal quality and external quality. So whenever you have a QA team, the QA team should be responsible for external quality normally, so the things that the customers see, but the internal quality of the application should be everybody's job. Concentrate on the test coverage. It's important that no piece of code that gets out of the window or out of the door is not properly covered and properly tested. Make tests meaningful, useful, and business-oriented. So it's important that the tests try to solve or try to cover the problems that the customers will have. You don't do tests just to tick a box. It's like problems that the customer will have. Will they be able to pay? Will they be able to buy that product? Will they be able to see that product? That kind of things. For continuous deployment, have in mind, deployment should not be scary or special. You shouldn't have a deploy day. Deploy days every single day. Don't make deployment scary. So the more you practice this, the more you do deployments, the less scary it becomes. Make deployments automatic. You shouldn't depend on anyone. Maybe tops have 1 click and off it goes. And if it doesn't work, another click to roll it back. Don't expect a team of people to coordinate to deploy something because that will fail at some point. Because I said, we're humans, we're not used to do repetitive stuff. Always have an automatic rollback, roll forward strategy. That's very important because that helps in your mean time to recovery. And ensure an audit trail of deployments. Do post-mortems. If something goes wrong, do a post-mortem. Understand what happened. Understand what you can learn out of it. And especially, understand when are you deploying. So you're on the top of the mountain. You feel quite smooth. You look a lot more fit than I am right now. You're the king of the world, right? But it's important to not think that you've done everything already because DevOps is a continuous thing. You need to keep learning. You need to keep doing. You need to keep improving because being on top is great, but the most difficult thing is not being on top, it's staying on top. It's staying lean. It's staying performant. So in summary, change is hard. It always creates tension, but understand where the tension comes from. Understand where your teams are. Have a mission, vision, and a plan. Measure everything. Get the feedback as early as you can. Understand what things are working, when things are not working, what people think. Create a target operating model, putting people always first. Transform your applications to be anti-fragile where possible. Automation and testing are key in order to gain speed. Reduce fear of deployment and rollback by automation. And the job is never finished. Keep iterating, keep changing, keep going. There's always something good. So last thing, I'll leave you food for thought. So if you want to read some good books, so anyone here have read any of these books? Yeah, very, very good. And the last one, which is amazing, is called Flow. This is a bit more dark in a way. I would say not everyone knows this one, but it's an incredibly good book to understand how people and teams work. So yeah, sail away. Done.
Probably got time for one or two questions. If anyone's got any questions? No?
No.
Okay, good stuff.
Thank
Cheers,
you.
Mark. Next is Ruggero.
So, hi everyone. I'm Ruggero, and if I can use this, I'm actually the principal site reliability engineer at the platform team at Netquest. And my work is automation, security, and performance. And I prepared this talk mainly for an internal round of tech talks. And this talk is meant to stimulate discussion about the early adoption of security and related stuff on the DevOps workflow. So it's a beta release. I could call it alpha, and it's a cutted version of the original talk, so expect some incongruences. So in this talk we will talk about the cyber threats. It will be a small introduction for the one of us that doesn't know all this wording regarding the cyber threats. We will talk about how to automate the security on code and infrastructure. And we will talk a little about the culture and the change that we need to embrace to make this adoption of DevOps really working. So, part one, cyber threats. We will start just with the definition. That is the possibility of an attempt to alter, destroy, or however, to enter a system in internet and take advantage of it. More definition. All the bad things that happens in internet have actors, subjects, and this threat actor can be state agencies, terrorists, criminal groups, or whoever is trying to leverage vulnerabilities to gain unauthorized control to systems, in order to stall data, or make disruptions, or own a service to do other stuff. Then we have the advanced persistent threat, that is when a threat actor breaches in and remains undetected for a long time and can take advances of this breach to move laterally to pawn another service or another system. And sometimes the word advanced is just used to indicate a group of people that use some 0 days or some information that it isn't public yet. Then, now the weapons that the villains are using. Phishing. I think that everyone here knows what is phishing. Sphere phishing is no for everyone, apart from my ex-colleagues. The target phishing is more or less the same of phishing. Instead of being generally targeted phishing is phishing made just to attack one company in particular. Maybe, I don't know, this threat actor want to own or want to needs data from the Groupon, and they make phishing especially crafted to attack people that works for Groupon or Groupon C-levels. And this malware can contain links to download malware or Trojan that will permit the attacker to enter the system in Groupon. Then we have another weapon that are your devices. There's a kind of attack that is called weaponizing your own device. So we know that Joao works for Shipster. Now, no. We can make a malware that is especially suited for Joao, maybe a malware that is get 5 free entrances to the Camp Nou to see the Barca, and Joao will buy it for sure. Joao will enter Shipster. Maybe someone didn't protect it or partitioned the guest Wi-Fi, and we can enter the target. Then we have the distributed denial of service, made usually with botnets. And another threat that is raising nowadays is the use of artificial intelligence to understand the behavior of people and to take advantage from this to attack a target. Then, which are the weaknesses that these bad guys are leveraging? Software vulnerability, as usual. We know that a lot of applications are vulnerable to SQL injection, cross-site scripting. There are 0 days that you can buy in the internet without using even the darknet. Infrastructure has vulnerability. Every week we read on Twitter, this kind of Cisco has a vulnerability, has a backdoor, whichever. Maybe today what we bought is super secure, and next week there's already a 0 day in the darknet, or maybe your friend is calling you, oh, we have a 0 day for this appliance. Does it interest to you? And then we have the supply chain hijacking that can be for hardware and even for software and even for hardware. We know that it's not that paranoid to buy company's laptop not on the normal supply chains. Sometimes we can hijack even the software supply chain. That was the same thing that happened to Node.js a few months ago. Someone started to help the maintainer of one packet, and 1 week after, there were some Node.js package stealing credential, or I don't remember what. I'm sorry. And then there's the human. Every one of us has some affections, has some, let's call it, hobbies. And you never know what the villain will leverage to enter your system or steal credentials. And then, which are the goals? Stealing money, stealing credit card numbers, stealing personal information that can be used to produce another type of attack, or just to leverage software engineering. I mean, you can steal the birthday and the social security number of one guy, call to his office. Hi, I'm Ruggero. I need to access to this server, but I forgot the password. And you're in. Then data. Data is one of the most important, most valued thing that we have in our companies. And an attacker can steal it, simply. Just think to the Ashley Madison hack. A lot of people in our companies and in our bank here in Spain are still on this list. And maybe it's not the best thing to get the promotion that you are waiting from years. And then you can install intellectual properties, like the formula of the Coca-Cola, maybe, or maybe to change it. Why not? Then here there are some numbers taken from various sources. I'm not gonna comment it because my 15 minutes are more or less out. I will publish these numbers. Maybe we can comment this after. But however, the number that are important here are the number of attacks per day and the number of devices pawned by day. Another number that is really important here is the percentage of data that is stolen but is encrypted, is illusory. I mean, in 2019, it seems impossible that just the 3% of what is stolen is encrypted. Maybe we can think, well, people that encrypt things are not being attacked with success. Or maybe there are just a lot of people that are not encrypting data on his company. These are more numbers, billions and billions and trillions of money wasted or paid in damage or just for security bias. Now, of all that I say, the two things are important. Cyber threats and security risks are for real. The number that passed before said so. And the other thing that is important, that everyone is a target. I mean, you can be targeted for your phone just because you are working for a company. You can be targeted because we need computing power to mine some new digital coin. And then this is the really important part, and this is what we can do to automate and fix this. This is the fantastic and glorious circles of DevOps. And what we have to understand that is we need to add a lot of tests more and security tests. So what we can do is basically to know us better. First of all, we have to identify the attack surfaces with external recognition, in-house pen testing, using OSINT tools, and then we have to know what we are running. I mean, which version of this Java library we are using. If the code is available because it's open source, maybe have someone that knows that is able to understand if this code can be leveraged for something. And always identify the origin of what we are using or embedding in our applications. Then, a set of methods that are in Hodge from a few years, made by Microsoft, strangely, is thread modeling, and is based on answering to 4 questions for every application that we are creating. So, what we are building, what can go wrong with what we are building, what we can do to fix this, and in the end, do we did a good enough job? When all these answers have, all these questions have their answer, we can move on. Then another thing that we can do for know us better and even to train the new guys is to run game days or chaos engineering days, depends on your religion. And this is for test the skills, your knowledge, and even the resiliency of the platform you build. Then, another thing that we need to, everyone needs to understand that we have to start early to bringing the security people in our software release, in our craftsman of the software, because it's worth nothing that when you are ready to release, these guys, girls run tests, and no, go back. It's a waste of money, a waste of time from everyone. And maybe the thing that you are constructing, even if we are the top architect or whatever, maybe there is some concept that is wrong since day 0. And then another thing that is work to talk is to create a better definition of done and to add security tests and better unity test to our definition of done. It's being tested, there's documentation, it has been security tested, okay, we can go on. Then, another thing that is nice to have is the continuous code analysis. There are tools, open source tools and commercial tools that we can run against our code base and even against the libraries that we are bundling. And even with tools that are just analyzing our code style, we can detect some bad behavioral or security anti-pattern. Then, once the application is in QA, we can run external tests on the application, functional tests, negative tests, and even, again, pen testing, external pen testing on our QA infra that should be exactly the same on the external surface as the production. Then, we need to run external auditing at least every 6 months, because, yet again, we can be the ultra mega guru, we can have the better people, but we are human. We can pass over an error, we can, you don't know, people always have bad days. And then on the deployed infra, you still have to run external testing. I mean, you have always to run auditing on your deploy infrastructure, because you can be sure even with all the automation you can put in place, you can be sure that for one error, maybe an error of your provider, you're depending on the VPC or the WAF configuration for the security of your application because you didn't have the time to fix something. And tomorrow, the provider changes some rules without noticing, and you're doomed. Then, other thing that we should add in our library is the zero trust networking or architecture. Trust no one. Every connection, even between our servers in our web farm, for those of you who are still on-premise, needs certificates or other ways to authenticate. And then a security measure for the poors, let's call it, is to raise cattle and not pets. If your system here is more or less failing on the security side, continuously cycling servers, containers, or pods can help, but with really big comillas. I'm sorry. Thank you. Oi, more slides, maybe. Yeah. Another thing that we should always think about, the minimum privilege approach. I mean, I'm on infra, basically, and there's always someone asking, why can't I have the permission to run this on the production infrastructure? Because you don't need this. I mean, you don't need an access to S3 if your application just uses SQS. There's no... Even if your manager says so. If you just use SQS, you have to have access to SQS and only to the queue that you are using, not to everyone. There's no time for asterisks nowadays. And then I would like to talk about the rugged software movement, but we have to pass. Seriously. You can talk with me later or Google this. Is another way, another approach to security in DevOps. There's DevSecOps, there's other buzzwords, and there's this movement that is more or less the same, but focusing on being rugged. Then, the last slide on what we can do, I suppose, is to adapt and use observability and anomaly detection, because there are things that we can maybe don't see or we can't get with the monitoring tools, but anomaly detection is really useful. I mean, you don't have to check the graphs. If you have a tool that analyzes the different curves on the graph for you and check and sees that there are 100 or 1,000 more of reset password this day. I mean, it's anomalous, but you can't keep with all the graphs that people put in the dashboards. I mean, you need some tool to manage this. And then, and I think that is the last, yes, deception. This is normally a military tool that is being ported to IT and security recently, more or less. Is the new gold stream for the cyber threats companies. It's 2 or 3 years that is the marketing buzzword. Am I right? Yeah. I mean, you can create... you can use honeypots even in your applications. you can put beacons and use beaconed tokens on your application, on your servers. You can use, for example, a login path that is not really the login path, but put in the login path a token, maybe in the comments of the JavaScript of this path, put the famous, don't use this in production. This is the production token is here just to pass the tests. And you can fool people with this token. Maybe there's an application of people at Accenture, maybe, I forgot this. This is spreading false Amazon credentials just to see who is interested on this service for this company. And I saw 2 implementations of this on application, and there are a lot of script kiddies that are still trying to understand where they are. But for the one that have more or less my age, this is a recall of the $6 million. Application security is not yet doomed. We can rebuild it or automate it better. We have the technology to do so and the capability to change workflow, the thinking, and to spread more awareness, because not all the managers and the people with the money in the company are aware of all this. I mean, we are asking for this tool to improve our security. We are asking to more time for doing this or adopting that. But people is still, there are someone that is still, oh, wait, we just have bought a new firewall yesterday. Why do you need money? Because our firewall is for the office and not for the applications. It's a tough war. This is the more opinionated part, I think. To go on with this movement that is to adopt security at all, we need a blame-free environment, even for coding. Is fundamental, but for security stuff is maybe as important as, because not everyone and not every developer or every system engineer is a guru on security side. And by the way, everyone has to learn every day. I think that no one is born with security skill level 10. No one. And then we have to encourage experimentation. I mean, it's easy to say we need to adopt the deception. Yeah, but people need to play with it, needs to try it even in production with all the... Then we should adopt the philosophy that Google is using running their postmortem. There's no blame. There's just an incident, a list of root causes, and no guilty. There's no point on saying this is your fault, because simply there's no point. It's just losing time. We need to focus on the lesson that we learn from these failures. We need to understand that, I don't know, the configuration of the load balancer can be governed by automated configuration tool and not left to the senior guy or the too old guy in the office. we still need to run blameless retro for coding, for infra, and for security. As before, there's no need to point the finger because it's just pointless and waste of time. Then, to make everyone understand what is running, what every team is doing, especially the security team, even is our hope is that the security guys or girls are sitting in the same office as the other guys, is to tell everyone why this is wrong. Just don't wait 2 weeks after your test to send an email. This cannot be deployed. This is wrong. This is, we have a SQL injection on the main page, on the landing page. No. We just have to keep the feedback loop short, super short, and we hope the same day or maybe in the same time you are running the test and discovered this, go ask for the change. The same as upper. And then security guys, or even infra, depending on how you are organized, it's not to be blockers, because being a blocker can cause you problem with the upper management, with the tech leads, and whatever. There's no point, even here, on being rude or just point finger. You have done this wrong. No. And that's it.
Perfect. Thanks very much. Sorry, probably haven't got time for a question this time, actually. But yeah, I'm sure you're hanging around later. If you've got any questions, just come and find.
Hello, everyone. Hope you enjoy the pizza. Just to say at the beginning, I'm super stressed, so just be prepared for me saying some random stuff. Quick survey at the beginning. How many people use AWS here and are familiar with AWS? Okay, cool. Quite a lot. That's good. Who knows what SSH is? More. Perfect. And I hope you use Bastion host, but we'll talk about it later. So a little bit about me. I'm a senior security engineer here in Adevinta. I've been with the company for like over 3 years now. Well, over 2 years now. My current focus is on system security, Kubernetes, and machine learning platforms. I used to do IoT, so I think I caught all the buzzword Pokemons, which is cool. And in my spare time, I really like to ski and watch and read sci-fi. But back to the topic. So I will briefly talk about AWS shared responsibility model because it helps to understand the concept. I will describe what system manager is. This is the service that's going to be used to maybe deprecate SSH, and then how we can get shell without SSH. Small demo, and hopefully there will be some questions. So AWS has this thing called shared responsibility model. Since they are a cloud provider, they are responsible for certain things, but still quite a lot of responsibility lays on the customer itself. Everything depends on a service, so responsibility when it comes to serverless is different than if we are going just for EC2. So it also works. It works in security. It works with reliability. So if they provide US3, then the storage, they are responsible for security of the storage of your objects. And when they provide EC2 for you, they are responsible for that hypervisor is not hacked. But still, if whatever you run on your instance, you are responsible for it. So if you're not updating your packages, you're vulnerable, and you open ports and stuff, then it's your problem. AWS is not going to take care of it. They will help you to run patches or whatever, but it's still up to you to take care of it. So what is Systems Manager? It's quite a big service. It has a lot of different features. We just focus on one, on Session Manager, but just a brief explanation. So it will allow you to create resource groups, where you can combine different, for example, EC2 instances as a single resource. So imagine you have a project which contains a front-end server and a back-end server, and you can combine it in a single group. It will give you visibility to your resources, easier access to CloudWatch logs. For example, you can create inventories to see what is running on the host, automate certain tasks, like, for example, updates, remote code execution in a good way. And you can, as I said, schedule patches, schedule them in a certain time frame. Distributor is pretty cool because you can update packages remotely, or you can create your own packages that will be automatically installed in a good way. State Manager will monitor the state of your applications, sort of like Ansible contacting your nodes and checking what is there. Parameter Store is part of also of the Systems Manager. It's used for secure. For example, one of the things is you can securely distribute secrets to your nodes without a hassle, and also you can just, for example, distribute configs and other things. And the main point of this talk, a Session Manager, which will allow you to access your nodes easily. Well, access nodes are basically giving you a shell. Pre-requirements for Systems Manager. You have to run AWS SSM agent, which is which is available in all recent AWS MEIs. So Amazon Linux 1, Amazon Linux 2, it's already available there. Except, for example, ECS or EKS optimized MEIs, they don't have it, so you have to pre-install it. But there are, the agent supports Windows, supports all the Linux distributions, and as far as I remember, it's also supporting Raspbian, so you can run it at home, on-prem, not mini-prem. It supports AWS endpoints. For those who don't know, AWS endpoints basically allows you to run, give you access to the EC2, for example, to EC2 API or to any kind of API without access to the internet. So you just, instead of going out through your internet gateway, you contact a certain endpoint in your VPC and then you have access to it. So yeah, you need to have access to AWS API to use this service. And from a client side, you can use Web Console, which is kind of you just log into your web UI in Amazon, and you can SSH to your gain shell access on your machine, or in case if you want to use AWS CLI or some other tools, you have to download I call it proprietary plugin, because the source code is not yet available, though they say they will eventually open source it. And install it on your machine. And as far as I know, they support all the platforms, Linux, Mac, and Windows. super fast. So disadvantages of System Manager. It is an interesting service, but a Session Manager is not like a silver bullet. It not solve all of your problems. It's not a drop-in replacement for SSH. If your developers rely on forwarding traffic to, for example, from your node to a database, from your application node to the database, this thing won't work. It will not help you. You don't have a secure copy, so you will have to somehow transfer your files to the instance in a different way. For example, through a distributor or S3, and then pull it from S3 to your machine. And as I said, Session Manager plugin is closed sourced, and therefore we cannot take the code and embed it in other tools. We have to actually exec the process to actually use it. So it's another CLI that you have to have on your machine. And also underneath it's using WebSockets. Like, I don't know if it's a plus or minus, depends on what people think. So in normal scenario, when you SSH to your machine, when you try to access to your host, you expose a port. So it has to be available. It has to be open to the internet. Of course, you can firewall it with security group, network access list, but still it's more or less this design. So you have your VPC, you have your subnet, you have your internet gateway. Hopefully you have your Bastion host, which is actually super secure box. This is only exposing SSH, and then you jump to the actual node that you want to access. But in this case, you have to worry about how to distribute public keys to all the nodes, how to or certificates, depend how you're using your SSH, or God forbid you're using passwords, but still you have to provide passwords. Then you have to provide passwords to everybody. Then you have to figure out how to authenticate users if you want to differentiate what kind of between actual developer and what Linux user is running on the box. Maybe you will have your LDAP infrastructure running that will identify it for you, or you could identify based on certificates or the keys, but still you will have to maintain all that. Of course, there are tools that are doing it for you, but still it's another piece that you have to maintain. With SSM, it works in a different way. You have a host. You have the agent installed that is doing a lot of things. One of them is it's calling home. So it's calling to AWS API, and it's establishing a connection. In this example, it's just using going to the API through Internet Gateway, meaning if your node has access to the internet, you can easily use it. You don't have to set up anything extra. It could be like this in a public subnet. It could be in a private subnet with traffic routed through a NAT gateway. Then you're calling home, and your client, so you or your developers, are connecting to AWS and then establishing a session in the node. Why this is good? Because the access is, everything is managed in AWS. So you leverage IAM. Who's familiar with AWS IAM? Yay, awesome. For those who are not or were too lazy to raise their hands, it's Identity Access Manager, and based on policies, you can actually give different levels of access to AWS services. In this case, we treat access to the host as a service. And here, there are tons of ways how to secure your access. You can, you can just download your keys, user keys, and then use them. You can use short-lived tokens. You can use all sorts of things. But still access to AWS, and you can easily restrict it. If you are more paranoid, or you have more critical infrastructure, you can see that compared to the previous slide, you don't have internet gateway. So that node cannot access the outside world. And for some of you, it might be a requirement. It could be a regulation. It could be, I don't know. It could be just a way how you designed your infrastructure because it's safer. Though you have access to AWS API through VPC endpoints. Who's familiar with VPC endpoints? Okay, quite a lot of people. For you who are not, think of a VPC endpoint as another instance that is running in your VPC, in your subnet. It's treated as an elastic network interface that is running and is accepting traffic based on certain criteria. For example, you expose a network interface that is accepting SNS traffic. In this case, in case of session manager, you need to have, to fully work with it, you need to have, as far as I remember, four VPC endpoints. Is a EC2 endpoint, EC2 messages, SSM, and SSM messages. In a demo that I prepared, I have a fifth one, CloudFormation endpoint, just to be able to actually deploy the node. So we are accessing AWS through VPC endpoint. Again, no exposed ports. Agent is calling home. You just need outgoing traffic. Oh yeah, demo time. Or maybe I'll do it a little bit different. I'll start with showing you the cool thing about AWS. Okay. Shit. Okay. You can trust me when I'm saying that because I mentioned that it's good for regulations. Sorry, I'm not going to show you because it will be slow. Because compared to Bastion host, when you had, let's go back to the presentation. Maybe it will be easier. What? No, it's okay. Just like fire out the cable. Nah, relax. That's okay. I mean, it's just people can see it in their own consoles, right? What? Why it's not loading? Oh, I don't. Okay, cool. Beer for anyone who can guess my password out of those. Shit, you get a beer. Where? Wow, it's so super slow. Okay, so when we had the Bastion infrastructure, for example, to get the logs of each user to record the session, we had to ship it either from a Bastion or from the node itself. Again, we have to worry about delivery. What if, for some reason, logging agent is not working? We are not delivering the logs. We don't have access to the logs. Or in case the box is compromised, attacker can modify the logs and basically erase the trace. In this case, everything is done in AWS. So we can export those session logs to S3, to CloudWatch logs. I was going to show it, but you can just believe me and check it in documentation or in your own consoles. You can also, which is super cool, encrypt it. So you can leverage KMS, Key Management Service, also provided by AWS, to store those logs encrypted and just decrypt it when you actually need it for audit or for some reasons. So your developers don't have access to it, so they cannot tamper it except removing it. Of course, since it requires API calls, all the API calls are automatically stored in CloudTrail. CloudTrail, for you who don't know, is basically a 90-day log of all API calls you have in the region. It's free from AWS. And all the session logs. So actually, the content of the session, which you're going to store either CloudWatch logs or S3, you have to pay for it. Yeah, but that's what you get. Okay. So I have 2 instances deployed. I have those 2 examples. One is public in a VPC that is in a subnet that has access to the internet, and in a different case, I have VPC that doesn't have access to the internet. Yet, still, I can get a shell on those machines. Okay, if I remember correctly. Magic happens. So you can see that I'm not using actually a AWS CLI. This is the cool tool. I don't remember the name of the company. I think it's 99 Design or something like that. AWS Vault for security storing. That's what she said. It's okay. So a lot of clears, yeah, I know. So AWS Vault, it's a cool tool for storing AWS credentials. It can use your keychain, or you can use GPG, a lot of crypto providers. And Sigil is a tool I wrote to actually easily manage access to the instances. Because as you can, I can show you. As you can see, here you have a list of instances. Let's take, we are in public. So we will have only access to public instance, but we can, okay, let's do it like this. We can use AWS CLI just to show you that it works. And and bam, we have a shell access. Okay, let's see. It's supposed to be public, so maybe it will work. Yep, it is. We are redirected. It means we have access to the internet. Okay. We can go and check another instance. You might notice that I'm using different profiles. Those are the name of the AWS profile. I'm using pub, and I will use private, just to show you that you can have IAM controls on. You can set up in IAM. here exactly is the example, code example, that you can specify a tag that, for example, on a tag, you can specify to which instances you have access in your start session action. So still allowing access to all resources, but specifying based on the name. So let's try to do this and take a private. Yep. As expected, it failed horribly. You are not authorized to perform a start session on the resource. Okay, let's see what will happen if we take private. It's private or priv? Priv, I think. Let's see. Okay, it works. Cool, we're in. Cool. Let's see if we have internet access. Demo works. So we are trying to connect. It won't resolve. It won't find an IP address for google.com because we don't have internet gateway inside. Yeah. And yeah, because this is exactly this. We just have access to AWS API, not all, because we only deployed specific endpoints. So, for example, if you want to access from this node SNS, you won't be able because you won't resolve. Yep. Any questions?
Any questions at all? No? Okay.
Cool. Thank you.
And up last, we've got Girish.
Hey guys, my name is Girish. I come from Canada. I'm here for KubeCon, so I'm not sure how many here are actually coming to KubeCon because you guys work for a great company. Yeah, awesome. This is not my first time here. I presented at DockerCon 6 months back, which was here as well. So this is my second time at Barcelona, but this is the first time at a meetup in Barcelona. It's really exciting to actually see a lot show up, given that this is the first meetup. That's fantastic. Actually, great job to actually you guys to socialize it. And also first off, thanks a lot for having me here. So this is a wonderful opportunity for me to actually talk in front of some Barcelona people. Hopefully, I'll probably do a better job tomorrow. I don't know. Anyways. So the topic of my presentation here is not specifically service meshes, but before I go into the service mesh topic, how many of you here do know what a service mesh is? All right. Okay. I'll see if I can, give a 2-minute talk about what a service mesh is before I jump into talking about the specifics of what I'm going to talk about. So one of the eventual, you guys are, mostly you guys are DevOps. So one of the trends you would have obviously seen is actually the movement of infrastructure concern from the application code into kind of its own piece now. Now, eventually, the trend is that it's not just the infrastructure code, because, my application shouldn't know what platform it's running on. My application shouldn't know how many instances it's running on, etc. Now, so that's the first step of infrastructure concern. Now, there is this other level of concern, that now in the world of microservices, so there are more and more challenges, and some of you guys, actually, have been talking about, the move towards, agile and, the shifting and the challenges that's presenting. So it's great, but, that move also has a lot of pain. So what a service mesh does is actually help you further the motion or the notion of moving infrastructure concern away from infrastructure. Now, but specifically, it doesn't service mesh doesn't help you with auto scaling. Obviously not. It's not probably going to help you a lot with service discovery. All those are infrastructure concerns essentially, but usually that's handed off by an orchestration platform, or a cloud platform, whatever is the right thing, for your infrastructure. Now beyond that, now in the world of microservices, so we are, when there are more services, people are actually facing more challenges in the sense, hey, so I'm talking to service A, and behind the scene, with some monitoring capabilities, which the infrastructure has, you as a developer, you don't have the insight of, hey, which service did it fail on? I mean, it's not that you cannot get that just from infrastructure monitoring, but there's beyond that, as to what was a specific thing that failed on, why did it fail, what was a request that it failed on, etc. Right? So this is where all the other things came in, where. You would have heard of Prometheus. So obviously, and instrumenting the code with Prometheus is actually the next step. Now that's definitely a great direction. But then there are also these other parts, for example, distributed tracing, so which again, people are actually, the best thing to do is, so they actually, bring in libraries which are doing a great job, no doubt about it. The same thing, for example, if you guys know what a circuit breaker pattern is, have you guys heard of a circuit breaker pattern? Awesome. So a circuit breaker pattern, for the rest, again, he said, maybe you guys are tired, pizza is too much, probably, having fun with your beer. So a circuit breaker pattern, especially when services are talking to one another, there is this component called service circuit breaker. It's a design pattern. Very popular implementation library is actually Netflix's. It's called Hystrix. Once Netflix actually created it, it was so popular, it's open source. Java. Sorry, I should have mentioned that first. So, but then the problem with that is that now, so here comes the challenge. So now more and more people are leaning towards microservices. More and more polyglot is coming in. So now the advantage with that is that, hey, so you have a small team. And you guys are developing an awesome service, great. But then so there could be developers that hey, this group knows Java, that group knows Ruby, while these guys know Python, and I am a Go developer. I'm just saying. So now what microservices is doing eventually is that it's kind of eliminating the need for being stuck with one language, which is great. But now comes a challenge that okay, so Java guys are using Netflix Hystrix, while Ruby guys are using your own library, while these guys are using their own library. Now, assume this case where there are 500 services. Now, every 500 service has an implementation of, your circuit breaker, for example, and you guys are all using Java, but your microservice is using Java 1.6, and it's using an old version of Netflix or Hystrix. And these guys are actually working on Java 8, and they have another version of Hystrix, while the old libraries have not yet been updated. I mean, so this is a ripple effect, So one of the things that service meshes are now working towards is actually moving all these into an infrastructure concern and kind of giving the power to the operators of the infrastructure to be able to kind of bring these enforcements as part of policies, so that you as developers don't have to actually do all kinds of things like this. It's not just this. It could be network policies. It could be hey, so here's a service, there's a service. I don't want these services to talk to one another. I mean, people would say, hey, I can just bring in network policies and bring in that restriction. But then now comes the problem where in the field of Kubernetes, when containers are so kind of ephemeral, network policies only help so far. So now there are situations when you guys are doing a canary testing. So I'm saying, hey, I want only some traffic to go here, while I don't want the rest of the traffic to go there. I mean, so all these challenges, are some of the things which service meshes are addressing. So now the good thing with them is that they are actually kind of moving all these and giving the power to the operator, so who, based on policies, can actually kind of very easily operate all this, so that a developer doesn't have to know. And I'm sorry, I mentioned canary. Do you guys know what a canary is? So a canary is this was, again, a very recent development. It's becoming really popular in the recent years. So canary is So rather than having a global rollout of a service, what they do is they actually release it to a small, like in production, like if you want to test a service, they release it to a smaller percentage of the end users. And based on like, the feedback, they get from the system. By feedback, I'm saying like the monitoring metrics and like ensuring that like, everything is normal. They kind of like, increase the number of people like, they're testing with. And then gradually, if everything is good, it actually goes to 100%. If it doesn't, like, the rollback immediately happens. And there are some systems which can actually help you do it like, in an automated fashion. So one of the popular service meshes is Istio. You guys can actually search for it. It's an open source project. It was started by Google, IBM, and a few other big companies. It's really popular now. Now, what Istio did is actually, Istio is one of the popular projects which has been addressing all these concerns. But the last part, like, which I said, Istio can actually do traffic shifting, so which means you can incorporate Canary, but it doesn't do it in an automated fashion. Now, that's where there is another project called Flagger from WeWorks, which actually works with Istio and, can do this thing in an automated fashion. So I'm just giving you an example, like, so service meshes is a lot. Istio is one. Another very popular one in the area is Linkerd. If you've used Java, like, and especially like, banks, financial institutions, like, they have been using Linkerd. But Linkerd also was very powerful, like, in terms of feature. But recently, like, they actually released a version 2, which was a complete rewrite because the earlier version was Java-based. And it had a slightly different architecture. So in order to make it much better, they've actually moved to a, kind of a different architecture. Now, but in that new release, it's not feature rich as the previous version. So it has, it has some less capabilities, but it's still powerful enough. Like, it gives you the visibility, like, people are looking for. Like within a matter of minutes, you can actually like install it. So every service mesh is great. But then, this space is now pretty much like beaming hot. Like, there are more players, like, there'll be like more things which are built on top of it, et cetera, and so on and so forth. So anyway, so I'm not trying to talk about service meshes, but I'm just trying to give you a taste of what a service mesh can do. So literally people are interested. So last year alone, I've given talk on Istio, like I've given a workshop on Istio 4 times at all the major conferences, like KubeCon twice, DockerCon twice, and like, always my hall is like 200 plus people, and it's always full. All I'm trying to say is that the domain is so freaking hot, but it's all good. It's awesome. It tastes wonderful. Like, everything is there. Interestingly, in the crowd, we always have DevOps engineers who raise 2 awesome questions, which is exactly like, what I'm going to cover. So service meshes are great. So now in this talk, like I'm going to kind of cover topics as to, so it's great, but what's the cost? Like, so what are all the possible costs? Like, I'm probably not going to have all the answers, but, I'm going to probably lean towards some, like, which might hopefully address. And especially, like, so when people are always asking, yeah, this is great. Now there are these service meshes. So now, like, so which one should I try? Like, how do I go about it? Like, this is kind of the next question that comes, because from a developer's perspective, hey, you know what? I don't have to, now all the infrastructure concern is kind of getting away from my code. So I just have to focus on my business logic. So that's fantastic. And from a company perspective, that's great. Because every change doesn't have to be a deployment, which is kind of like, so the companies love it, right? So who is responsible for maintaining the service mesh? That's where you guys are there. Perfect audience here. So exactly. Yeah. So it's a good thing. It's not a bad thing. So the thing is that, apart from all the other infrastructure stuff you guys are working with and living with and, like, running daily, service mesh is going to become one of the major components that every company is going to start using. Already there are too many people, like, using Linkerd, for example. Now, Istio is if you guys, once you know what Istio is, you'll know that it's a beast. It's not easy to actually, tame. Same thing with Kubernetes. Like, everybody wants to jump into Kubernetes, but then when you guys, I think some already mentioned that it has its challenges. It has a beast. And that is the reason why there are so many companies in that space who are willing to run Kubernetes for you guys. I'm just saying, like, so that's how beaming, like, these spots are. So in this talk, like, one of the major questions, like I said, that kept coming up is, okay, now, I'm interested in adopting a mesh, but then which one do I go about is probably like, one or two questions, like, which I'm going to try to answer or, kind of like, point to. So before I actually go further, you probably saw in the first slide that I did talk about service meshes, etc. And I just introduced myself. So I'm now representing Layer 5 IO. Now Layer 5 IO is actually not a company. It is a community. So this community was very recently created. Whenever you guys have a minute, please check out layer5.io. You'll understand, what this community is trying to do. Essentially, this is one of the major problems or questions we are trying to answer. So now, once we created this community, you can see here that, so this is actually a snapshot from the site. So there is a section we created, it's called the service mesh landscape. So now, and this is actually probably not up to date. So there are so many service meshes that are still coming up. Again, you can see, not everything is a service mesh here. The left column is kind of, based on the most recent commits, I will say that's the list of service meshes that have come forward to kind of let people know through Layer 5 that they exist. All the others on the right are like client libraries, API gateways, service proxies, load balancers. Now, of course, the title says service mesh landscape, but then why are we listing the rest? I'll kind of be touching on that as well. So this is actually an interesting one. So this is just to give you an example. So I just talked about two, I just mentioned the word Istio, and I just mentioned the word Linkerd. There's each one is probably you can write too many books about them. That's how big the topic is. But you can see here that already there's an Aspen Mesh, but Aspen Mesh is actually more of a SaaS management for Istio company. It's actually part of F5. If you guys know F5, Nginx is now part of F5. Yeah, so that F5 console. If you guys have been using console for service discovery, that's great. I believe you guys know what console is. If you guys don't know, yeah, great, awesome, awesome, yeah, okay, great. If you guys don't know, it's mainly, I wouldn't just say that it's a service discovery tool. That's a bad thing to say. It's much more than that. And especially recently, what they have done is, it's from HashiCorp. What they have done is recently they have added a capability called Connect, which is kind of it is, I will say, it gives features like a service mesh. So that is there. And of course, there are some other companies, which you can definitely go to layer5.io and check out, what they are. So now moving on to the exact question, which I'm trying to answer in this presentation is, so what service mesh to use? Like I said, this is kind of, but usually the second question that comes, the first question that keeps coming up is, what's the catch? What is the cost? What am I paying to get all these benefits is actually the first question. And like it's stated here, so what overhead does a service mesh incur is actually one of the first questions that keeps coming up. And interestingly, when we actually delve into the analysis, you probably might see the value. Yes, and before we, so anytime somebody comes up and asks, okay, so which service mesh to use, there is never a good answer for that, because, mostly, since you guys are from a DevOps background, you guys know that it's not usually that kind of a question which is helpful. It's usually what do you want is actually the question. So based on that is how you have to go searching for the answer. So, yeah, so obviously, there's no one good answer there. So, since you guys are not too familiar with service meshes, I'm going to actually touch a bit on service mesh architecture. You know what? I'm given the time. I know it's a bit late, so I'm just going to see if I can just cut to the chase and run it down. So if you look at the diagram here, so a service mesh has several components. For example, when you talk about Kubernetes, you cannot just say Kubernetes is this one thing, right? So it has a lot of components in it, which make it a platform for running your services. So in a similar fashion, service meshes, usually, so this is not a norm or a standard as of today, service meshes, have different flavors, like I said. Some provide an ingress gateway, some don't, some provide an egress gateway, some don't, etc. But most popular architecture is kind of here, where, so there is an ingress gateway, based on, it's usually helpful for, capturing the incoming traffic, so that it can help you monitor and give extra metadata right from the entry point. And then the egress gateway is usually for the exiting traffic. Again, these are not mandatory components. Then comes the data plane. Data plane is actually very, very important because, that's kind of the place where your application is running. So, and you can see, as it's mentioned there, it actually touches every packet request in the system, is what is mentioned there. So that's what. So obviously that's the data plane, right? It's playing a crucial role in the communication between your services, and also managing your services in a way. And also the data plane is responsible for service discovery, health checking, client side load balancing is what I should say. Then authentication, authorization, and observability. So if you just talk about a data plane for a service mesh, these are usually are the best things you can get out of it. Which is and pretty much from a developer perspective, the cost is really, really negligible. It's from the operator's perspective, it's a bit. So essentially, so you can see that, as I mentioned, it's further push of infrastructure concern from the developer towards the operator. Now, assume this case that you have 10 microservices. Now, when we talk about a service mesh, what that really means is that usually there is a sidecar sitting either at the node level or per service level, whatever it could be. It doesn't have to be Kubernetes. Kubernetes is the best example, but then it doesn't have to be that way. So usually that's a sidecar, so it's either running at the node level or the service level. So the traffic essentially is going through each of them. So the performance of the data plane is really crucial. Now, like I said, it's a sidecar. You already have 10 services. Now each one has a sidecar. Now again, who's going to manage the configuration of those? If we do it individually, it's very painful. So that's where usually a control plane component is very helpful, because it helps you to manage the data plane. So you can see the control plane actually helps with providing policy, configuration, platform integration, which means it could integrate with the underlying infrastructure or the orchestrator you guys are using. And then again, so it's the control plane's responsibility to actually convert your existing services into a service mesh, or make your services run on a service mesh, essentially. But yes, and they do not touch the packets, so it's the data plane's responsibility. Now, on top of that, could be something which is much more intelligent, but existing data meshes do not provide that. But I'm pretty sure they're all working towards it, or always there are other companies that are coming into that space, which could actually provide monitoring, backend system integration, expand the policy and application configuration, etc. So overall, at a super high level, probably 10,000 feet, a service mesh, if you have several components in this, then you probably can say it's a service mesh. So here is a sample application. Now, this is a very specific example, which is, if you guys, have heard of Istio. Now, this is it's called a canonical book info example of Istio. So what this is trying to explain here, or it touches on some of the points I actually mentioned to you guys, is the first thing you can see is multiple languages, polyglot, so there's Python, Ruby, Java, and then Go, for example. So, and you can see all these services are communicating with one another. So this is an ideal microservices polyglot example. Now, with Istio, this is how the communication will look like. So there is an ingress gateway. So earlier in this case, you can see that the traffic actually was coming to the pod. It doesn't have to be a direct one. There could be an ingress controller, or it could just be a node port, or a load balancer, or whatever it is. So essentially the traffic was directly coming to the pods. Each pod was talking to the other pod, through the service discovery mechanisms in place. But here you can see that the communication is not direct. So you can see this Envoy sidecar is sitting right next to each and every one of them. So this is actually that sidecar which I was talking about. Now, all these sidecars together is what make the mesh. So that's Istio. Of course, the control plane is not shown here, but here this one is trying to explain how your existing set of services would or their communication look like when there is a service mesh. Now, what does this give you? A lot of advantages, like I said, including MTLS. Again, it's an optional thing, but one of the major things, or one of the major factors people consider a service mesh for is actually MTLS, which is mutual TLS. Moving towards again, what some of the presenters already spoke about, which is total zero trust. So that's one major thing. So here is an Istio architecture. Like I said, I'm not going to go inside this, but this is how the architecture of Istio is. In the previous slide, I showed the data plane, how the communication is happening. But at the top, you can see there are some other control plane components like Pilot, Galley, Citadel, Mixer, and more. But essentially, so this is how the entire architecture of the control plane along with the data plane looks like. And you can see the application traffic is coming directly to the ingress gateway, not touching the control plane, and being directed between services. And of course, some external calls are being made through the egress gateway, etc. So that's one example of a service mesh. Now here is another one. So this is the other one I was talking to you about, Linkerd. So you can see Linkerd does not have an ingress gateway or an egress gateway today. So here's an example. But then even the new version of Linkerd has a sidecar proxy, which actually runs with every pod, if you know what I'm talking about on a Kubernetes land. But then again, there is a control plane, and the control plane has all these other components. And of course, your monitoring, et cetera, comes there as well. So, yeah, so we touched on service mesh. So one of the next set of questions is that, it was presented, a few minutes back that a journey, a company's journey towards, becoming agile is not going to be a quick change. It's kind of, there needs to be a culture in place. So it's a process. So it's all these put together that makes the transformation a successful one. So in a similar way, when companies, like I said, service meshes, yay. That's the first thing that comes. But then the transformation is not easy, especially when companies have 500 services. Even if it is 100 microservices, it's not easy. It's really painful. So usually some of the models which are recommended, are the first thing is, so it's moving one step at a time is kind of what they say, and doing it in a very slow, consistent pace is what's recommended. So as a first example, you can see at the bottom, not sure of the point. Okay, so at the bottom you can see a collection of VMs running some APIs. And then, of course, earlier, the client was talking to the edge cache, and the edge cache would probably be, kind of sending all the non-static traffic to, the VMs or something. So now, as a first step, for example, in a case with Istio, if people want to migrate to Istio or kind of want to adopt Istio, what they could do is they could actually first bring in the gateway, which can act as the, you guys probably are more familiar with the API gateway pattern. So this is pretty much identical to that. So instead of something else, you can use the Istio gateway, which is based off of Envoy, and and that can actually route the traffic to the VMs. So this is a very successful pattern. Given the time, I'm just going to run faster. So this is the next pattern, which is proxy per node, where this is the pattern of the previous Linkerd, which is Linkerd 1.0, 1x, where they had an agent per node. It's not per service. So on the node, there could be there could be 10 or 15 services running, but then there will be just one agent per node. So this is the next pattern, and obviously the other pattern, here is an example of a router mesh pattern, where you have an ingress controller, but then that actually sends traffic to another component, which will manage the traffic internal to the mesh. So this is kind of the next step is usually what's recommended. And obviously the final step is bringing sidecars with all the services. and going. So these are some of the patterns that are successful. Now, Lee Calcutt is actually one of the founders of Layer 5. So he actually wrote a book on enterprise path to service mesh architectures. So the book is freely available. Layer 5 IO/books. You should be able to get a copy of this book. Where he is kind of talking about this journey of how companies are transforming and how service meshes are eventually kind of the next step there. So now we actually spoke about some options for transformation. What kind of? I'm sorry. Yeah, no worries. Yeah, take it down. So obviously now that we've kind of touched really at a micro level or probably at a nano level, we've touched on what service mesh is, some service mesh architectures, and some deployment models people use for transforming into complete service mesh usage. So what we did is, like I said, 4 times in a row, we were asked the same sort of question. So earlier this year, it's probably 3 months back, what we did was we actually started this project. It's called Meshry. It's an open source project. The main purpose of the project is to kind of eventually answer these questions. So now, again, it's just been 3 months, so we are definitely making progress. So we welcome more contributions. So feel free to take a look at the project. It'll be very helpful if more and more people are participating. We have a weekly community call that's happening. You can find all that information on the Layer 5 IO site. I have the site open here, so it's the Layer 5 IO/Meshry. It gives you some details, pretty much. It talks about the architecture of Meshry and some presentations. And here you can see there is a weekly call. We also record our call. It's on YouTube, so if you guys are interested, that'll be a good starting point. So, sorry. So, like I said, so that is Meshry. As a very simple start. I'm not trying to, again, talk too much about Meshry given the time. So this is kind of the simplest architecture we have as of today. So what we have done is we first started off with, again, the same journey. We started off with a simple monolith proof of concept. And then eventually we thought, hey, you know what? We started off for Istio mainly. And then we decided, yeah, you know what? Maybe we should answer this question much more broadly. So we wanted to actually work with multiple meshes. So this tool, in order to enable that, we created this concept called adapters. So, and you can see the Meshry is kind of the app, and the app talks to the adapters over gRPC. And in this case, as of today, Meshry is kind of tied to Kubernetes because that was a good start for us. And most of the meshes today work on Kubernetes, so that was an obvious start. So what the Meshry adapters do is they actually talk to the Kube API servers, which actually gets the job done. That is one part of Meshry, which is the playground aspect. So if you want to see, how your app is going to behave on a mesh, that's the one phase. Now the other phase is, okay, now that you have a mesh, for example, deployed on a test cluster or something, and you want to see how that is performing with your app. So that's the other phase of Meshry, which is kind of the load testing capability. So what we have tried to do is we've tried to put them together in a single tool, and that's kind of what Meshry is or is becoming. And now I think I'm already over time, so I'm just going to run through them. So we did some tests. And we found, you can see the blue line is the Istio's specific profile. Istio is, again, very configurable. But so there was this MTLS on tracing off profile, which is compared with Linkerd because we were trying to compare apples to apples because Linkerd does not have tracing but has MTLS as of now. So that's kind of a profile. So here is an example. And at the bottom, you can actually see the data that the more cores and threads we allocate, you can see the latency kind of fluctuate. So that's one example. So this is kind of the next test where we were actually comparing it with to another configuration of Istio, so the default configuration and the MTLS on tracing off with Linkerd, and you can see how the performance of the default was much worse. because this one has tracing while these two don't have tracing. Like for example, so those are some of the options that which Meshry is trying to address, trying to give you the answers for. And here is again another stats as to how it behaves when you are downloading different sizes of responses. Again, so that's 10 megabytes, 10 kilobytes, etc. And then now this is kind of the interesting part, where, so this probably is one good slide which answers one typical question. Okay, so what is the overhead? What am I getting for it? So here's a slide which actually shows that over time, the Istio namespace, Istio system namespace, which is kind of the control plane for Istio, its memory usage is kind of, you can see it's constantly building, and it doesn't seem to come down. Same thing for Linkerd, and you can see how the whole thing is behaving. So these are some of the questions that we're trying to address. Now this is a data plane. Now that one was control plane components. Now this is data plane. Now the yellow here is actually the sidecar. The same thing here is the sidecar for Linkerd. So you can see in an ideal situation, Istio's sidecar's memory consumption is higher, but under load, interestingly, we found that Istio's sidecar performance was much better than Linkerd's. So yeah, there are some examples again. And more. And here again, I'm just trying to compare the idle CPU utilization versus load for the control plane. The same thing for the memory utilization, the data plane CPU utilization, and the memory utilization, etc. So those are some of the things which again, like I said, Meshry is eventually trying to help answer, which again is a community project. So it's not backed by any company. Like I said, Layer 5 is a community. And this is a community project. Now, as part of this, obviously we wanted this to be kind of much more adopted in a bigger level. So what we are also working on, again, it's not just us, with contributions from other people, is actually a spec, so that we call it the benchmark spec. So that every time you run a test, you can actually kind of record that data and eventually compare that with your own spec, or maybe you can make it globally available within your company or outside, so that others can benefit from it as well. So this is a very initial, it's in very alpha stage, I would say. So here are, for example, as of today, here are a list of contributors we have. Who have actually made it possible, made Meshry possible. So there's another book that Lee is working on. It's called Istio Up and Running. If you guys are interested to know much more about Istio, this gives a good coverage, but it is in its finishing up stages. I think it's ready for review, in the sense it's available for public review. So if you guys are interested, again, if you go to Layer 5 IO, you should be able to see it. I did want to demo Meshry, so as in its current state, but given the time, I'm not going to. So you can see here that, essentially, it gives you an interface for running some load test. Here, it'll actually show the client-side metrics, but then the next question came as to, okay, now how do I see the server-side metrics? So what we did was we integrated it with Grafana, and you can see, right now my VPN is disconnected, but otherwise, so the point is we are trying to give a platform where you can run tests, see the client metrics along with how the server-side components are behaving in a single pane of glass. And we also persist the results, so you can actually compare them. You can see them, for example, this was a test which I did a few minutes back with an older test I did, and you can see how different they are, for example. And you can actually use some comparison features we have built right there. So. And the other component is the playground component, which lets you connect to a cluster. And so here's the Kubernetes part, here are the adapters part, and here's the Grafana configuration. So once you do this, you can, I think you get the picture. So yeah, given the time, I'm not going to go further. But if you have any questions, feel free to reach out to us. There is a Slack channel. It's open to everybody. So, if you're interested, please join our Slack and join our community call on Fridays. And it'll be great to actually have more folks. And this audience, seems very precisely fit for that, because, you guys are mostly DevOps. So, yeah. Thank you, guys.
Thanks very much, Girish. Yeah, unfortunately, I think we need to leave at 9:30 as well. Is that the curfew? So I think we've run out of time. So try and grab Girish if you have any questions. I just wanted to say thanks a lot again for hosting. Really appreciate that, and thanks to the speakers.